All right, we're going to take a look at problem number 2 here. It says the area of the triangle below is 25 square units. Our job is to find the value of h here and then to find the measure of the missing sides, which are right here, over on the left and over on the right. I'm going to start by labeling the vertices of the triangle that is given, and that is A, B, and C. The next thing I'm going to do is highlight this triangle in red so that we can refer to it as the red triangle. All right, with everything labeled, let's turn our attention to this statement about the area of the triangle. We're told that the area is 25 square units. I also know that the area of any particular triangle is just 1/2 the product of its base times its height. This triangle has a base of 6 plus 4, that makes 10, and it has an area of 25. So I'm going to replace A with 25, and I'm going to replace B for the base with 10, and leave H as our unknown. 25 equals 1/2 times 10, that'll be 5, times H. And we know the product of 5 and 5 gives 25, so the height of this particular triangle must be 5. I'm going to go ahead and add that to our figure. So we've found the value of h. Now let's see how we can tackle those missing sides. I notice that the dashed line is showing an altitude. It's drawn from vertex B out to the opposite side, and it forms a right angle, so I can be assured that I've created a right triangle here. So I'm going to outline in blue a new right triangle, and I'm going to go ahead and add a vertex label here as D. So I've got this little blue triangle BDC. It is a right triangle because we've got a right angle here, and 90 and 90 makes 180. I can actually use the Pythagorean theorem here to find the value of the side length BC. So that'll be 5 squared plus 4 squared equals side length BC squared. Since 41 is a prime number, I cannot simplify this any further. There are no perfect square factors of 41. We have BC is the square root of 41. We're going to do the exact same thing over on the other side. I have created yet another right triangle, and that is the triangle BDA, which I'm highlighting in green. Again, this is a right triangle. I have that 90-degree angle showing, and I have, once again, the height and the base of this green triangle. That means I can use the Pythagorean theorem to solve for the line segment AB, which is that last missing side. All right, once again, a radical that cannot be simplified. I do not have any perfect square factors of 61. So for line segment AB, I just have the square root of 61, which cannot be simplified any further.